All right, so this is how the lesson's going to work today for us. I'm just going to record the lesson as if I was teaching you directly. Unfortunately, you won't be able to ask any questions, but feel free to pause the video if you need to write something down. I've also included some guided notes for you that follow the flip chart along. So if you wanted to get that first before continuing with the video, feel free to do that. So I'm going to go ahead and start going over the warm-up. So the very first thing we need to recognize is what it means to be a hypotenuse. Well, the idea of a hypotenuse is the side opposite the right angle. And when we say opposite, what we're saying basically is the side that doesn't touch the right angle. So if I go and find my right angle, which is indicated by this square thing in the corner, and I go to the opposite side of that, the side that doesn't actually touch the angle itself, I see that that's this piece right here. That is AB. And so I'm going to label that as 15 like the directions told me to. Now, some people say that it's the longest side. It is actually the longest side, but without measurements on there, without knowing whether the diagram is to scale, we can't really make that judgment. All right, next I need to label the side that is adjacent. So we need that word adjacent and what that would mean. And adjacent means that it's actually touching. So it's part of the angle A. It's a ray that makes up the angle A. So if I go to angle A and I look for the side, well, this one's already marked as the hypotenuse. It's actually not a side. So the only one left is this piece over here. So that's the one that's adjacent to angle A because it's making up part of that angle. It's touching angle A. So I will label that one as 12 like it said. And I made a little bit of mistake up here. That's not supposed to be meters. That's supposed to be centimeters. And then the last one says the side opposite angle A. And again, opposite means not touching. So if I go to angle A, the only side that is not touching the angle itself, 15 is touching it and the 12 is touching it. This side over here is the one that's not touching it. So that's the one that is opposite. So I will label that as 9 centimeters. Okay? So we have to make sure we know those pieces before we can get into the concepts for today's lesson. To use the Pythagorean theorem, well, hopefully you remember the Pythagorean theorem is a squared plus b squared equals c squared. So to use that to show that the triangle is right, basically we just need to find out that these two sides of this equation are equal. And once we prove that they're equal, then we've shown that the triangle is a right triangle. Now, to figure out what side A is and B and C, what we need to remember is the connection to the angles. So angles are usually listed as your capital letters, and sides are listed as your lowercase letters. And the side itself is actually opposite the angle with the same letter. So that means then that this is side A. If I find angle B and go to the opposite of that, that is side B. And if I look for angle C, the piece that's opposite of that is up here. So now I know my side pieces. So A is 9, B is 12, and C is 15. So I'm going to go ahead and square those individual pieces. So that gets me 81, 144, and 225. And when I add these two together, I get 225. This is what's considered an algebraic proof. Basically, we work through the algebra until we get both sides of our equation equivalent. That's an algebraic proof, okay? Not like the geometric proofs that you did last year, which is where you had to make the two columns and put the explanations down. All right, so today what we're going to be looking at is the right triangle trig functions. And you should have gone over these in geometry, but it might have been towards the end of last year, so we're going to make sure you remember them. So we're going to learn 3 right triangle trigonometric ratios so that we can solve for missing sides and missing angles. The key to these today is that every triangle we work with is going to have to be a right triangle. That's the only way these trig ratios work, is if we're dealing with a right triangle. So we have to make sure something's told us along the way that it's a right triangle. We can't just go based off of how it looks. Okay. All right. So first thing we have to do is we have to practice making sure that we know which side is opposite, which side is adjacent, what's the hypotenuse, no matter what orientation the triangle has. So that's what this first thing is doing. So pause the video here and see if you can answer these questions before I go over them. All right, so hopefully you took a second to go and see if you could answer the questions on your own. If not, I'm going to go ahead and do them here. And if you did, this is a good opportunity to check and see if you got it right. So if I'm going to name the side that is opposite angle C, the first thing I have to do is identify C. And remember, opposite means the piece that's not touching it. So we go all the way across. So that side is AB. To name the angle that's opposite AC, I first have to find the side AC. And again, we're talking about opposite, so we're talking about the angle that doesn't touch. So it has to be angle B. Okay, and this one here, we're going to name the side that's adjacent to angle A. Okay, well, first we have to figure out which is the side, which is the hypotenuse. Remember, the hypotenuse is opposite the 90-degree angle, and they've shown me the 90-degree angle here, so this must be the hypotenuse. So it's not going to be that one. Adjacent means it's touching, so it's not the hypotenuse, so it must be this other piece that makes up angle A. So that's going to be side AB. Now, if we're looking for the angle that's opposite side XY, here's our XY, and again, we're going to go to the opposite piece of that. The angle that's not touching that side at all is angle Z. And we want to name the side that's opposite angle X, so we find X and we go to the side that doesn't touch it at all, and it happens to be this side here, and that's side YZ. And then the last one is to name the side that's adjacent to angle Z. So again, this one, because we're talking about adjacent, we want the piece that's touching, but one of these is the hypotenuse and one of these is a side. So this one here we identify as the hypotenuse. So that means the side that we're looking for is actually YZ for this one, because that's the only thing that's touching it that's not the hypotenuse. Okay. So let's move on to the next piece. This is your right triangle trigonometric ratios. We talk about the sine, the cosine, and the tangent. Now, when you say these, it's a little pet peeve of mine. When we write them, we usually write the abbreviation SIN, but we still say sine because that's the word. We usually write this one as COS, and we say cosine, not cos. We say cosine. And the last one we abbreviate with TAN, but we still say tangent. Although we write the shortened form of it because that's how it shows up on our calculator keypad, we should say the entire thing. So when we're trying to find the ratio of the angles, the sine of the angle, what we do is we find the length of the side leg that's opposite the angle that we're talking about, and we divide it by the hypotenuse. When we're trying to find the cosine, we find the length of the leg that's adjacent to the angle we're referencing, and then divide by the hypotenuse. And when we're finding the tangent of that specific angle, we find the length of the leg that is opposite, and this time we divide by the length of the leg that is adjacent. Now, we abbreviate this as SOHCAHTOA, because this is your sine, and I'll write it like this. Sine equals the opposite divided by the hypotenuse. Cosine equals the adjacent divided by the hypotenuse. And tangent is going to be the opposite side divided by the adjacent side. That's what that abbreviation is talking about. So what I want to do is I actually want to look at what sides I'm talking about. All right, so the sine, let's just say we're talking about, because this one's labeled as angle A. Okay, that's what they've put theta, Theta. This is theta. It's a Greek letter that we use for angle measurements. So we want to do the sine of angle A. So we say the sine of A equals, and we want the leg that's opposite. So that's the opposite leg. So we would say BC, whatever that number is going to be, divided by the hypotenuse, and they've shown this is the hypotenuse. So that's going to be divided by whatever the value of the hypotenuse is. And then the cosine of A, so the cosine calls for the adjacent side. So the adjacent side to A is this one that's touching it, so that's AC. And it's also going to be divided by the hypotenuse, which is AB. Okay, and then the last one we look at is the tangent of A. And the tangent of A is going to be the opposite over the adjacent side. So the opposite side is your BC, and your adjacent side is your AC. Okay. Next, we're going to start putting some numbers on this. I have a limit of 15 minutes for each one of my videos, so I'm going to end the first one here, and we'll pick up with the next video right where we left off.